Awesome. Thank you very much, everybody, for joining the Microsoft Data Platform Continuity Virtual Group. This is the October 2022 session. I cannot believe this year is flying by so fast. With me this month is Tim Radney from SQLskills. I have known this gentleman for, geez, what, 12 years now?
Yeah, it's been
maybe
like
longer.
a dozen.
God, I'll put it this way. I trust Tim's opinion on this topic more than most people's fact. uh, Tim, absolute pleasure to have you on. I'm going to go ahead and turn this over to you for everybody. This is Understanding SQL Server Backups and Restores.
All right, well, David, thank you so much. And yes, gosh, it's been a minute, man, since we met in the SQL community, and it just kind of stuck together and grew up together.
It's been wild.
It has been an amazing journey. And this is one of my absolute favorite topics. As David, as you know, I mean, the fundamentals of being a data professional is making sure that you can recover in the event of a disaster. And in order to be able to recover, we need to have proper backups. And we hear people all the time say, "Oh, well, I need to develop a backup strategy," and we kind of cringe, and it's like, no. You need to plan a restore strategy. How do you recover those backups? What is your SLA? How long can you be down? How much data can you afford to lose? All of those things. And if you're like me, if you ever get to talk to people in person with that, and you see that their eyes just kind of gloss over, like, what are you talking about? I just need to be able to restore. And it's like, yes, but in a timely manner, right? All right, well, let's just go ahead and get started. So I am Tim Radney. My contact information is on the screen. I've written a few books. David, I don't know if we've worked together on a book, but you can tell from some of them it's understanding backup and recovery is two of them chapters in another book about backup and recovery, and then making SQL Server go pretty fast on Azure VMs. But my contact information, Tim at timradney.com, my blog at SQLskills.com, and my own personal blog when I can. But that's how you can find me. Also on Twitter occasionally. So with backup and restore, what are we going to talk about? I only have a few slides, honestly. The rest, we're going to jump into a couple of virtual machines and look at various recovery techniques. But first, we're going to cover your backup types and why SLAs matter. Which backup type is best for you or your organization. How do you know that backups are good? And then I'll briefly talk about an approach for backing up those large databases. And large is subjective. How big is big when you're dealing with data? Then really the main point of this is how to restore your backups. You got to have that proven restore strategy. How can you recover to a point in time? There's a thing called piecemeal restores that I love to kind of demo. And then we'll talk about having plans. And this is where David or I could go on and talk for days about having plans and what do you do and how to orchestrate those. So you need to have a solid restore strategy and then a proven disaster recovery plan. So jumping right in, service level agreements. Sorry, I had to close the window. A bird was getting too happy outside. So your recovery point objective, how much data can you afford to lose? Then your recovery time objective is how long can you be down? David, have you ever asked a customer those two questions?
Daily.
And what's the number one response? No downtime, no data loss.
The common response is always, well, we don't have it formally defined, but we can't lose anything and we need it back yesterday.
Yeah, pretty much. And then we start throwing out like massively large numbers of quantities of money to try to achieve that. And then we end up landing on something like, well, maybe 15 minutes of potential data loss, 5 minutes somewhere in that 5 to 15 minute from transaction log backups. And then, ultimately, how long can you be down? We start, hearing that in numbers of hours. I mean, 4 hours. So when you're talking about these types of events, in the sense of disaster recovery, that is the building is gone. No one can gain access to it. It's underwater or it's rubble. In that level event, how long can you be down? So we're moving the entire organization. Those numbers are more like 4 hours, 6, 8, 24, somewhere in there. data loss, you can still be down for an extended period of time, but minimize the amount of data loss from doing your transaction log backups and then replicating that immediately to an offsite location. So as we start talking these numbers, things begin to emerge. What do we need for disaster recovery? What do we need for high availability? Even in situations where you may have a window to restore a database, and let's say it's a 2-hour SLA for recovery time objective. It's a small database, no problem. You can restore it in 10 minutes. Now, all of a sudden, it's a half a terabyte database or a half a petabyte. Over time, databases get much larger. It takes longer to restore the larger, the more amount of data that you have. So depending on your recovery time objective, you may need a better HA solution. And this is where we start getting into availability groups and clustering and log shipping and those types of things. So if it's not a data center level event, it's isolated to your application. And I love these conversations. I know David, you've had these too, is where people are building out a disaster recovery, and it's a really nice, robust, 10 gig connection between, and they're thinking, oh, well, we have this very expensive, beautiful DR site. We can leverage it for HA. But for you to fail over, you have to fail over the building. So we're not going to fail over the building for your one application. So you have to build out high availability within a data center. And then you have the DR for that building level or much larger scale type event. So I love these conversations and kind of what it builds up. And what I tend to tell people is, as you're discovering this and you're seeing gaps, you may not have an HA solution and the company doesn't want to fund it. Just make sure you have that in email. And then every time there's a head of state change, new management comes in, bring it up again. I did this for years working for a financial institution. I went through like 26 managers in 18 years. So save those emails, they protect you. And then as management changes, eventually you'll find somebody that may want to fund it, and then you can sleep better at night. Until then, keep your resume up to date, just in case. That is your personal DR plan. So what types of backups and what's the right one for you? Traditionally, we see full backups. Those may be nightly. That could be weekly with a daily differential. We have file group level backups. So if you have a database with multiple files and in file groups, you can do file group level backups. That's more of a technique for those very large databases where you partition data and you have read-only file groups. You want to back up your read-write. If the read-only has been backed up and you can restore it, you don't have to back it up as often. Notice I said as often. You still want to have regular backups. We have file level, your log, that's your transaction log backup, and then copy only. That is a very important switch. If you're doing differential backups and for whatever reason you need to do a one-off full backup, you want to make sure to use with copy only so that you don't reset the differential bitmaps. So with that being said, some combination of those are going to be what's warranted to meet your service level agreements. And again, traditionally it's full with any database in full recovery, transaction log backups. Depending on size, doing a weekly full and daily differential can be beneficial to help reduce the amount of overall backup space that's required to hold your backup retention. I have a script here. I'm probably going to make some changes to this based on a session I gave at Data Saturday. This script will pull back the database name, the recovery model, the last full, the last differential, and the last 2 transaction logs. I've been using this since about the time I met David. I mean, it's just been a rock solid script that from that I can glean so much information. Any databases in full recovery with no transaction log backup. I see the last 2 transaction log backups. I can tell the time as long as they're recorded properly. So I can see how often they're doing transaction log backups. I can see if they're using differential. And then of course I have the database name. So some good information, database in full recovery with no transaction log backup. I know that transaction log is going to continue to grow and grow and grow. And we see this all the time. The worst case I've had is a customer reached out, had a 20 gig database with a 1.2 terabyte transaction log. He just kept throwing storage at it and was wondering why everything was so slow. And every time he restarted SQL, it took forever for that database to come online because it was having to go through the crash recovery. and it was, I forget the number of VLFs, but it was in the tens of thousands. So anyways, so I can tell a lot of information from that script. What I want to make some changes to is to make it availability group aware. So if I'm doing my backups off the secondary, not the primary, you wouldn't have to run this on both sides. But I don't know when I'll get around to that. All right, I mentioned very large databases, VLDBs. So how big is big? It depends. I have customers, I mean, for them, their 40 gigabyte database is massive. I'm like, I can fit like 20 of those on a thumb drive. And typically, to me, it's when I start getting into the hundreds and hundreds of gigabytes. So if I have a 500 gig database, and it's got 5 years worth of data, I mean, that's roughly 100 gig per year. I mean, I could start looking at that and considering, do I want to do any type of partitioning or archiving or things like that to make things easier. If the rate of data change is pretty small and it's a big database, then you're doing index maintenance and updating stats and all those things across a lot of stale data, but still has to be read. So being able to partition the non-updatable data out into read-only file groups could be beneficial for maintenance and things like that. So with that being said, you can partition a couple of different ways. You have your sliding window partition views. You can manually just move the data around. But the benefit here is it allows for a partial restore, meaning I can restore the read-write file groups and restore the read-only file groups later. So why is this significant? I have a terabyte database that would take me, let's just say, an hour to restore. There's only 100 gig of that terabyte that is read-write. That's data that's less than a year old that I would want to be online as fast as possible. Is it faster restore 100 gig or 1 terabyte? Typically the 100 gig. I mean, depending on where you're storing these things in your network and the speed of the disk and all of that, it might be a trivial point, but for most it's not. So if I can restore the read-write file group and have that data back online in minutes versus an hour, I can restore customer functionality or end user functionality much more quickly, and then start bringing that older data on at a later time. The point of being able to restore quick is to restore user functionality. And I'll demonstrate this. It's been quite beneficial for me back in the 2008 to 2010 timeframe. A multi-terabyte database on SQL Server 2005 that took more than a day to restore. Being able to partition the data and restore the read-write file group took us from over 24 hours to restore to less than an hour. That was significant. All right, recovering transactions. So you have some level of event, now you need to restore. What do? Well, first, if you can take a tail of the log backup, you need to. This means any transactions that have occurred since the last transaction log backup. So really a tail log backup is just a transaction log backup. It's just all the transactions that have occurred since the last one. So if you have access to take that tail end of the log, do so. That way you essentially minimize any data loss. I mean, depending on the type of event, I mean, you can have downtime, but 0 data loss. So in this case, we're able to take a tail log a tail log backup. We restore the last known good full. What do I mean by last known good full? It means the full backup that is good that we can restore, because we should be regularly validating these. There's been numerous times I've had customers reach out that they tried to restore their database and they could not, and they've never tested their backups. And for whatever reason, it was like malformed, couldn't recover from it. So we had to go back to something much older. So last known good full. And then if you're doing differentials, the most recent differential, and then restore the transaction log backup since either the last full or the differential, whichever you restored. And then lastly, the tail log backup. So that's the order of operations. Got to restore the base, which is your full, and then differential if you have them, and then transaction log since that point. Pretty straightforward, but if you're not familiar with the process and you haven't restored backups before, practice. I mean, Developer Edition is free. Go download it. use wide world importers, AdventureWorks, make up a database, just whatever. You'll have my sample databases I'm about to show. And practice doing this. You don't want the first time to be in the middle of the night when there is a production outage and you're trying to figure this stuff out. You have the experience doing it, know how to do it. A lot of folks have done maybe a full, but they've never applied transaction logs to it. They've only ever had to restore full down to dev, QA, something like that. Or they've done full and they've done some logs, but they've never tried one with a differential in the mix. So just practice. So we need to have a plan. Know how to recover. That's what I was just talking about. Test that your backups restore. If we were in a room, I'd say, hey, how many of you are in an organization that is regulated by some agency, some government, some entity, some warlord, that's dictating you must be SOC compliance or FDIC or whoever, to where they come in and make sure that you're following standards. If you're in that type of organization, which most of you probably are, if you have a restore validation process in place where you're doing this on a weekly or monthly basis, and you can show them the records, so document the stuff, everything is stored in MSDB, so output that out, show that you've restored the business critical systems once a month, and here's the reports and how long it took and how big it was and all of those things. You can script all of that out. One, it helps you validate that your backups are good. Two, it meets requirements for auditors and examiners. And it's just good practice. Have a disaster recovery plan. That's both you personally and your organization. If your organization doesn't have a really good one, you need a really good personal one. That means a network. So that's a SQL community, SQL family on Twitter, the SQL help. We've been asking questions. You have a network of people, so you can send out a tweet saying, hey, I'm looking for a job. That's your network. Your resume is up to date. That's your personal disaster recovery plan. Test that your disaster recovery plans, these need to be tested frequently. Oftentimes when I ask, how many have a DR plan? A few hands would go up. I'm like, okay, well, how often do you fail over to test? And they're like, well, either yearly or every 6 months. Okay, so do you fail over and run there for a period of time and then fell back? Oh no, we've simulated disaster. We bring things up, make sure people can log in and view data, and then we stay at our primary site. Okay, that's not a DR test. You're testing connectivity, but what about all the business continuity? So things like that, just you kind of dig. That's our jobs, right? To be paranoid and just make sure that you're comfortable with where you're at. And lastly, you need to know your facts. How long do the restores take? It's not always the restores, not necessarily the time it took to do the backup. How long does it take to restore that 0.5 terabyte database? Then how long does it take if there's a large disaster and everybody else is also doing restores and saturating the network? But having those numbers, and that can all come from that top bullet. Test that your backups restore. Have that restore validation process in place. You know how long these take. And so if you have that super critical system that 2 years ago only took 20 minutes to restore, and now it's taking an hour and a half, that's now an hour and a half into your SLA. Do you need to start looking at an HA solution? Those are the questions. That's why this is so important. That's why I'm so passionate about it. That's why David started this group. These are the things that people need to be thinking about and planning for. That's our job, to make sure that we can recover with minimal data loss. All right, let's go play. So I've got a virtual machine over here. So what I'm going to start off with, pretty straightforward. Since this is virtual, I don't feel like I really have to zoom in to anything, but we're going to restore. I just want to know that I'm back to a good base. Actually, let me get on the right. That's my stop at. Let me do the first one here. All right, so I'm just going to restore my sample database. And so this is backup sample. So I'm restoring from disk. So this is my base 2. So with no recovery, and I'm replacing. So I'm overriding. And then I'm restore database with recovery so that I can bring it on. Notice that I'm going through upgrades. So I'm running on SQL Server 2019. I've been doing this presentation for a long time. I believe this was originally built on 2008, might be 2012. So whatever version you would have, and I could go and look this up. So whatever version 782 is. This way, if you're restoring to a lower version, the source backup sample file, you should be able to restore it in something less than 2019. All right, just for good measure, I'm going to clear my backup history. This is something that if you're using Ola Hallegren or a third-party tool, it will regularly run sp_delete_backup history and pass a date. So I'm telling it to delete everything before tomorrow. So basically wipe out any history in MSDB for this demo purpose. In production, that would be like -30, -90, and that's only the metadata. It's not actually the backup files. It's just the history that showing every restore, every backup that has occurred and some data around it. So if I do a select top 10, we can see 75123 is my largest or my highest sales order ID. So what we're going to do is step through and simulate production. So David and I, we see a lot of customers that their backup routine for their transaction log is 15 minutes. So we're going to simulate some production data. So I'm going to do a full backup. So that's the backup sample base. We're going to do a log backup. We'll insert a transaction, 75150. We'll do a transaction log backup, inserting 75200. Another log backup, inserting 75250. And then a final log backup. So we can see the messages. I'm going to move this over. So we can see that we did a backup and the various ones, and we inserted some transactions. So what would our recovery script look like? What would be the process to recover if right now we had a catastrophic failure? So we had a full and quite a few transaction log backups. Do I restore just the full and the most recent transaction log, or do I need all the transaction log backups, log 1, 2, 3, and 4? Well, we can take a look. Let's just make sure that those transactions are there, and we can see them, 150, 200, 250. Now, I love code that generates code. So I have a script here that I've been using for years. And this is all available. If you've noticed on the slides, it said, hey, backup scripts are located here. So at timradney.com/presentations. Click on this presentation, you'll have all the code that I'm using. So this will generate the restore database backup sample from disk. So this is our full, and then log 1, 2, 3, 4. Notice they're all with no recovery. And then the final restore database backup sample with recovery. So it's pretty nice. You could incorporate this into your backup routine. Actually, there's also like DBA tools, if you're familiar with those, that you can loop through that will generate your restore script at any time. So you run the job or run that process, and it will generate the restore script. So what I've done for various customers over the years is every time a job would run, it would pass the database name to a stored procedure to generate this script. So if we had just done a full, it would say restore the full and then restore with recovery. If we had just done a diff, it would be the full, the diff, and then with recovery. If we had had a full, a differential, and we're an hour into running transaction logs, it would say full, diff, and then the logs up to that point. And it would output to the same location that we're writing the backup files. So at any point, we have from the most recent backup, the only thing we would need to go try to capture would be the tail of the log backup. So back up that tail end if we could. All right, so that was fulls. What if we're doing differentials? So just kind of gave that away. So we'll step through real quick, same process. I'm restoring a base 2, bringing it online. We'll clear my backup history. And then we're going to go through and do the same thing. But this time we're going to do the full backup, a log. We'll insert a transaction, 75150. We're doing a log backup. Now it's like nighttime. We're doing a differential. Inserting another transaction, and then a log backup, and then inserting a fourth transaction, 75500, and then a final log. So the sequence was like full, log, log, diff, log, log. So how do we restore this? Well, you have a couple of options. This particular script is saying if you're using differentials to include them. So if we take a look, we have our full, we have our differential, and then log 3 and 4. Now, could we restore the full, log 1, log 2, ignore the differential, log 3 and log 4? Absolutely. the differential is all data that has changed since the last full. So if that data had changed 100 times, it's still just going to be that last, how the page looked at the time the differential, ran. So it's allowing you to advance forward. So the data has been changed and then the logs, but you do not have to use the differential. So you can still go back to the full and replay every single transaction that has occurred. The diff, I get in trouble if I refer to it, an analogy as a cumulative log, because it really has nothing to do with the transaction log. It just allows me to skip those transaction log backups. It does complicate the restore a little bit since we're skipping the log chain, but it is quite beneficial. So if I have a terabyte database, I don't have to back up a terabyte every single night. I'm backing up the change data. So this is beneficial. I would say maybe 1 out of 50 or so customers I'm using differential backups with. And even those, it's typically just the larger databases. All right, let's look at piecemeal restore. This is one of my favorite. So now we're going to use another database called backup file group sample. So I'm going to restore it just so I know I'm in a good place. And let's take a look at it. I'm going to refresh. So look at databases, backup file group sample, look at the properties, and it should look familiar. I mean, we have our primary file group, or our data file, backup file group sample. So this is our in the primary file group and then our transaction log. So we look at file groups. We only have the one. So this is pretty much standard for any database. If I want to partition, then I need to create file groups and files. But what I want to show you right now is what data exists in this. So we have 121,173 rows, and the data is from 2017, 2018, 19, 20. I need to roll these forward in a couple of years. I think I had that code. Yeah. So I can just run update cells, set the modified date, add a year. I need to do that a couple more times. All right, we're going to partition, but first what I need to do is have a backup so I can restore back in case something happens. All I'm going to do is alter database, my backup file group sample, and I'm going to add a file group for 2019, 18, and 17. And then now I'm going to go and create files and associate to the respective file group. So a 2017 NDF, that stands for another data file, compared to M main data file and L log data file. Those are completely subjective. Just somebody at Microsoft came up with a fairly nifty naming standard. So I'll add those. Now let's partition. And all this is, I use the partition wizard and said, go through and partition to the individual file groups based upon the year data. Now let's take a look. Notice we have multiple files and they grew by 1 meg because by default it was 1 meg and then auto grow by 1 meg. That's best practice, right? No, it is not. But it works extremely well for this demo. So we can see that data actually did move around. And then under file groups, we have 2017, 18, 19, each has a single respective file. So we did partition data. Now, just in case I blow something up, I'm going to do a full backup. So this is my backup sample after. We can do file group level backups. This is basically a full backup because I'm specifying the primary in each secondary file group. So if I back this up, we can see the individual. So 10,080 pages for the backup file group sample, file 1, that's primary, 304 for the 2019, 96 for 2018, and 584 for 17. Just so you can see, I still have the same 121,000 rows. Nothing's changed. But now let's do something crazy. We're going to restore database, the backup file group sample. I'm only going to restore the primary file group. So from the after backup that we just made, I'm using with partial. It's the only time that you'll use this. So with partial means a partial restore. We're going to issue with recovery, and we're going to overwrite the existing. Wow, that's impressive. Let's take a look at the state of the database. The primary is online, 2017, 18, 19 are recovery pending. This is important. This statement right here, recovery pending, means additional files or backups can be restored. If we try to query greater than 2017, only restored the active, so that'd be like the 2020. So it's telling me one of the partitions of the index for sales resides in a file group 2017 that cannot be accessed because it's offline, restoring, or defunct. May limit the query results. Okay, let's restore 2017. Take a look, we see 2017 is online. If I query within 2017, so January 1 through 12/31, we see 45,000 records. We try to query greater than 2017, it tells us the same message, but now it's 2018. It said may limit query results. We go back to results. We see some, before we had 45,000, it stopped at 43,948. So it limited results, but we had some results. But if we query between January 1 or January 2020, January 2017, within the respective years, we have 95,000 results. So you can see where this can start becoming beneficial to an organization if your users are limited in the stored procedures, say in financial, they can only see back 90 days or something like that from the business internet banking, consumer online access, any of those types of applications, then this would absolutely work, no change. Backroom staff that have the ability to direct query or expand the range would need to know what's available, what's online for them to query. So we're going to go ahead and bring 2018 and 2019 online. We see everything there. Now we're going to query less than 2021, and we have our 121,000 records back. So how cool is that? Being able to restore just a portion of a database. All right, tail log. We're going to use the backups that we've already taken. All right, so this was our backup sample base, log 1, 2, 3, 4. Right, we'll view the top one, 75250. We're going to insert another transaction. And David may recognize the significance of the transaction that we're inserting. So we'll take a look at the top two. We have 75250 and 5 nines. Let's do something crazy. I'm going to use master. I'm going to alter my database and set it offline. Let's go take a look at, let's see. My SQL data folder, backup sample, delete. All right, so my backup sample database is gone. The MDF, I left the LDF there. I'm going to try to bring it back online. Of course, can't. Data file's not there. Let's refresh. Look at that, recovery pending. What if I try to back up the transaction log, backup sample to disk? Cannot be opened due to inaccessible files or insufficient memory or disk space. Look at the SQL Server log. Why? When you do a transaction log backup, what happens? A checkpoint is issued. Well, what if we do with no truncate? You don't issue a checkpoint, don't try to truncate the log, just back up. Wow. We just backed up 3 pages of a database transaction log file for a database that the MDF is gone. There's very little corruption that's more severe than the data file just not even existing. So we just backed it up. Let's see if we can restore. So we're going to restore same script as above, but we're going to include the tail log. All right, let's take a look at the. So we have the 75250 and the 5 nines. But wait, that was on the same server. What happens? if that's gone, I need to drag over another window here. Oh. So we're doing our transaction, our database backup, our transaction log backup. We're pushing those over to another environment. So we have those offsite. My entire server got, or the data line that includes master model MSDB is gone, but I still have access to the LDF drive. So in that case, if I still have access to the LDF, it's possible to still recover the tail end of the log. So we're on a server that, databases, there's no backup sample database. So we're going to go and create one. So create a backup sample. We're going to set that database offline. And I've already copied over the transaction log file in the backups. So we're going to do something similar to what we did before. I'm going to maximize this. I'm going to go into that SQL data folder. We just created this database. Notice it's 8 megabytes. We're going to delete the MDF. I'm going to go into my backup folder. Where do I get that? I'm going to grab the log file from the other server. I'm going to go into the SQL T log folder. I could delete this. I'm just going to overwrite it. So Control V, replace the file. Notice we go from 8 megabytes to 100 meg. So all we've done is created an empty database, deleted the data file, replaced the log file with our production log file. Now I tried to bring that database online. Same nasty message, but we refresh. We'll see it's recovery pending. Back up the log. Same as before. We backed up the tail end of a log for a database that didn't even exist on this server. So we created the empty shell, just create database statement, set it offline, deleted the data file, replaced the log file. So we were basically attaching the log file from one database to another. It's called a hack attach. And then we just backed up the tail end of the log. So those transactions we would not have lost. Now, will this take you a little bit more time in production? Yes. But zero data loss versus telling the world that you've lost customer data. So a few more minutes of downtime to save that reputational loss of losing data. So since we have our backups somewhere else, we restore. We take a look. And we have it. It's amazing. The fact that we can pull that off.
Just going to interrupt here. For anybody watching this after the fact or watching live, if you can't do this today, take these scripts, review this, practice this, because I'll be blunt, your career depends on this scenario. This is that critical of a situation.
Dave, the first time I gave this to a large audience was back when PASS was in, was it North Carolina, in Charlotte?
Yeah.
I had a lightning talk. And I gave this talk and somebody toward the front row broke down crying. Because 2 weeks before they had just lost, like, I forget how long the person said, it was like 12 minutes since the last transaction log backup. And so they only knew that they could recover to the last transaction log backup, that they had access to the log file and they could have done this, but they didn't know the technology existed to do it. And it was such an impact to the organization, and that the person just started crying.
It's that significant.
I mean, it truly is.
Yeah.
So thank you for that. All right. So encryption. Let me make sure that the certificates don't already exist. They look like they did. So with SQL Server 2014 introduced native SQL Server encryption. And so why would you want to use backup encryption? Well, anyone that has access to your unencrypted backup files can restore them to developer edition. Don't need any other key, no magic. So if you don't have TDE enabled, which if you're running in Azure, like Azure SQL Database Managed Instance, it's on by default. If you don't have any type of encryption that's encrypting the backups, I don't care about just encryption at rest. That's if I steal your storage array. If the file itself is not protected, then I can get it and restore it to a developer edition and see all your data. So SQL Server encryption or SQL Server backup encryption is kind of a big deal that so many organizations overlook because they have the checkbox that we have encryption at rest. Wonderful. That's just one of the problems. A buddy of mine said, well, that protects you if the Kool-Aid man breaks down the side of the data center and steals your storage array. But what about the bad actor that has access to your storage solution that has all the backup files and can just freely start copying stuff out?
All
Anybody heard of Target, Sony? I mean,
sorry, all I can say there is, oh yeah.
That's right. That's right. So this can absolutely help. So all we're going to do is create a master key. You have to have that to get started. We're going to create a certificate. So I'm just going to call it SQL Skills Encrypt Cert with the subject SQL Skills Backup Encryption Certificate. And then I'm going to back up the master key with a complex password. Gotta love that complex password. All right, so backup master key. Now we're going to back up the certificate. All right, we're going to run two scripts here. So we're going to back up the backup sample database with compression, with encryption. We're going to use the AES 256, and we're going to specify the certificate. And then we're going to do just a plain backup. No encryption, no compression, because can you compress an encrypted backup? So these went to C, SQL backup. We'll take a look, see SQL backup. So our compressed encrypted, we'll make this is 4.79 megabytes. The unencrypted is 16 megabytes. So about a 75% compression ratio. So to answer that question, yes, you can compress an encrypted backup. So what does this mean for doing restores? All right, I'm on the server that has the key. Here's my restore statement. Restore database from disk with replace. Works. I don't need to specify anything else. What if I'm on a server that does not have the certificate? So we remove it. Same syntax, restore database from disk. Certificate with that thumbprint does not exist. Okay, let's recreate the certificate. Same name, same everything. Attempt to restore. Thumbprint's different. It's unique every time it's created. So let's drop the bad one. How do you create, or how do you restore a certificate? Well, you have to create the certificate from file instead of restore certificate from file. I just find that amusing. We restore everything else, but we create this one from file. So this is why these passwords are important. If I did not remember my complex password that I used to encrypt the certificate when I backed it up, I have a very small virtual doorstop, meaning I can't then decrypt. I can't call Microsoft and say, hey, can you decrypt my encryption key that I backed up? So you have to keep up with these. So key management becomes important. And then we restore. It's pretty simple. So with this backup key that I created, so the certificate, you can have as many of these as you want. I say that there probably is a limitation. But let's say you have a consolidation server and you have 5 different applications and you want to back up each different databases with a certain cert that ties to that application. Absolutely, you can do that. You can get as complicated as you want. So what do you do if you're using this and you have an HA server, a DR server, any of those? Well, when you create their certificate, then you go over to the ones that need this and you go ahead and create from disk. So you do this on all the other servers that you know at some point you may need to restore this to. So HADR, development, I mean, whatever you need. And then it's just there, and then it's just normal restores. So pretty straightforward and easy to use. I'm not going to dive into this and do a demo. I just want to show you the syntax. Using backup to URL was introduced in, I need to look it back up, but it was like SQL Server 2012, Service Pack 1, cumulative update, something. It was an odd release where it came out in a CU back in 2012, but we say it was a 2014 release because that's when the version of Management Studio actually supported restoring from it. Prior to that, it was T-SQL. So backup database to URL, you specify the blob storage, you have to create a credential, and that's it. the restore is restore database from URL and specify the credential. And your credential would be your, you get that from the Azure portal, would be the key, and pretty straightforward and easy to do. I primarily only use this when I'm doing Azure migrations. That's about it. Why? Well, if I have a customer that has an express route, then okay. If we have a pretty fat pipe and we're basically using Azure as an extension of the data center, awesome. Otherwise, I'm limited to the bandwidth to do this restore. And my restores, every customer I've ever worked with, an organization, it needs to be as fast as possible. And over my Starlink internet is not as the fastest possible route. It doesn't compete with local disk. So what I would want is I want my database backups as close as possible for my primary restore. Then I want them as fast as possible for a secondary. This is a good third option in that case, to have offsite backups. It's also a great option to leverage this and then have an Azure virtual machine restoring, kind of like a log shipping type situation, so that I can have a very, very inexpensive DR solution. But just know that exists. Now, this is the last demo and one of my favorites as well. So we're going to do a piece, or in this case, a true point in time. So we're going to restore to a known time. So it's using our, this is another database called pre-pit, pre-point in time. This is the code I used to create 10 transactions that were like 30 seconds apart. So I created a table and then insert into with a wait for delay. So if we take a look, so we run that syntax, we do a log backup, we restore after that. We'll take a look. So we restore our pre-pit and then the backup sample point in time. So our transaction. So we just ran that block of code, created 10 transactions, and it's all in that one transaction log. So we can see the different times that the transactions occurred. So if I want to stop at a particular point in time, how would I do that? So I can restore the database, so the full with no recovery, replace, restore the log with stop at, and I'm telling it what point in time in this file that I want to stop at. That's it. So what I'm telling you here is that you can stop at a particular point in time within a restore of a transaction log. So this contains all the bad things. Maybe this was the time that the update statement without a where clause happened, or the truncate table, or the delete without a where, whatever it is, you can stop before that bad event. So let's take a look. So because this was 235707.347, that's where we stopped. So we have everything prior to that. If I flip this to, let's say, a 9, we now have that 6th transaction because 349 is after 347. So again, like David was saying, this is very important, because by the time you got the call, you may have 1 or 2 transaction logs that, from the oops, phone call or ticket gets to you, minutes have passed, another transaction log backup has run. So you have transactions that have occurred after, but the person said, as soon as I ran it, I looked and it was 259 or 249. That's after 245 and before 3 o'clock. But you have that 3 o'clock transaction log backup. What can you do? Restore with stop at 248. So you're still going to have data loss, things that have occurred after that, but you can at least get back to before that event. Then you could still try to piece together anything else within the database, but you don't have to stop at 245 if you know this happened at 249. So it's getting into some forensics, and my friend Cleve is probably also has used the DBN or FNDB log to kind of roll through trying to find when events happen to get as close to the tragedy as possible, to minimize data loss. But just know that, I mean, this is another restore technique. And I plan on in the near future to put together a similar session to this, but with kind of backup techniques, where we can talk about how to speed up backups with different number of files and block size and all those types of things to really kind of dive deeper into the backup and restore technologies. But that is it for the demos. As I've mentioned, slides and demo code, timradney.com/presentations. I want to thank you all for jumping in and attending this session. Oddly enough, one of these similar talk that I gave to the SQL Down Under group, the videos out on YouTube's had like 70,000 views. So it's like an amazing topic, but I just wonder, of those 70,000, was it people that were then needing to restore and trying to find resources? I mean, how does that happen? But all the demos that I showed you, the code's out there, a version of the slide deck is out there. I think the only thing that's different in the slide deck is the title slide. But if you have any questions, anything comes up, you feel free to shoot me an email, tim@timradney.com, or hit me up on Twitter @tradney. So you can tell I love this stuff. I mean, it's we can't stress how important it is, but unfortunately, it's one of those topics that people don't really, you seem to give a lot of care and attention to until after the fact.
Yep.
And it's so sad.
It's one of those things, love it or hate it, you have to know how to do this, especially for high transaction rate systems, things where quite literally, I mean, we've got one company lost track because of this scenario where they shipped a pacemaker to. That's a problem. That's a real problem. So thank you very, very much. This, like I said, this is arguably the foundational tenet of your job, period.
Right.
If you can't do this, performance tuning, different levels of availability architectures, you name it, all that's secondary to making sure that this foundational component is intact and in place, and you're able to act on this quickly without Googling in the event of an emergency. So if you have not mastered this topic, and I stress that word, you need to take some time, sit back, get caffeinated up, and just play, tinker, experiment, go through these scripts. It's absolutely vital for not only your career, your job, but the business. Businesses can fail if you don't master this stuff.
The number of times I've seen it, the emails that come in through the queue because of the company I work for, and where they hit an event, whether it be some level of corruption or whether it be ransomware or whatever. And they go back and we're like, well, how far back do your backups go? And it's like, that's the thing. Our backup job started failing like 4 months ago and nobody noticed. And we have a copy from development that was refreshed like 6 months ago. Can you help us? And it's like, where do we send the condolences card? I mean,
yeah.
It's like you're hamstrung. You're extremely limited, and I mean this hasn't even gotten into DBCC check DB in recovering from consistency issues and things like that. I mean there's so many things. I mean SQL Server, I love it. It's an incredible product, but it's only human, and so many things. I mean the amount of data change that's happening when you think about from being read into memory to the storage fabric underneath with caching and everything else before it can get to disk. I mean, the chances of an extent getting zeroed out. I mean, it's rare, but it's not
not zero. It's not zero.
Right.
Yeah.
And so being able to restore, minimizing the data loss. I mean, that hack attach, I've joked and said, I mean, this is your next promotion. It's your next 2-week paid holiday. It's, an extra week of vacation. It's whatever you want it to be because you can hold it ransom. I mean, it's it's that important and critical. And ultimately, if you're responsible for the protection of the data, this is your foundation.
Yeah. Let me know when you want to do a follow-up session on integrity checks. I'd love to see that.
Yeah.
Yeah. And we can make that one as long as you want.
Yeah.
Does not have to be limited to an hour. And if we want to go all day, you just tell me when.
Yeah, and that one might be something we have to do for a close circle and be under NDA. I mean, that's giving away some trade secrets there.
We can arrange that.
That's right. I mean, break open that hex editor and start doing some manual page repairs.
You let me know when and how, and we'll make it happen, because that is arguably the second most important tenet of being a DBA. Awesome. Well, thank you very, very much. Just like you said, contact info is up there. Presentation links are on the screen. If you are watching this after the fact, don't hesitate to reach out to him or to us with any of the questions you have. We're here to help. Nobody gets paid for doing any of this stuff. We're here because we want to be. And that means not only are we here to answer your questions, but if you have topics you want to see, let us know. We will write presentations just for you. If we have 2 people show up to a session, I'm thrilled. We're here to help, we're here to educate, and we're here to all learn together. That's the bottom line. This is a tight SQL Server community, Microsoft Data Platform community. We want to help. So let us know if you like this. Let us know if you want to see anything new, especially from Tim or any of the other folks we've had on the last couple of years. And share this with functionally everybody that manages data in your organization. We will have the link up on YouTube within the next 2-3 hours probably. And share this. And I'm talking, do a learn at lunch, set a goal, experiment, block off some time and play with this stuff. Of every one of the sessions we've had on this virtual chapter, this is the most important topic, hands down. So thank you very much, Tim. Thank you, everybody, for tuning in live. Thank you, everybody, for watching this after the fact. And we will see you next month.
All right. Thanks, Dave.